Giving an AI agent direct access to a shell environment carries inherent risk. An agent executing commands autonomously can act wrongly without asking. Look at this split-screen terminal. On the left, an agent safely runs a simple grep command to read an invoice. On the right, it attempts to overwrite the file entirely. The instinct is to secure this with a complex rules engine. You might write glob patterns to whitelist commands, but static patterns struggle with the sheer variety of valid commands an agent generates. The Claude Managed Engines architecture explicitly rejects these complex static rule languages in favor of a binary toggle. The entire permission vocabulary for server-run tools consists of exactly two policies: always allow and always ask. This minimalism is a deliberate design choice. This moves the point of control from a static configuration file directly into the live interaction between the AI agent and your application code. This dual domain architecture shows client application code on the left and the Claude server harness on the right. Policies govern only the server-run tools inside this perimeter, pre-build tools like Bash and MCP tools. Custom tools sit outside, residing in your application code. Since your application is the one actually executing custom tools, you already hold the decision. The approval is simply an if statement in your own handler. Permissions exist for tools you don't run yourself. Without a policy, the agent could act on the server and you'd only find out afterward. Your code governs custom tools. Harness policies govern server tools. Nothing falls between. The policies decide whether a tool runs automatically or pauses to wait for your approval. Toolsets had asymmetric defaults. The agent toolset defaults to always allow. The MCP toolset defaults to always ask. Built-in tools are fixed, running automatically, but an MCP server is a moving target. Its capabilities change, so it safely asks until explicitly trusted. When configuring an agent, the goal is to trust the safe tools and gate the dangerous ones. You do this by setting a permissive baseline in the default.config and then carving out exceptions. In the configs array, you can explicitly set tools like bash or write to always ask. This setup creates a frictionless experience for read-only operations while ensuring the agent cannot modify files or execute shell commands without your oversight. The principle is simple. Trust guarantees to run automatically, but gate the tools that can change the world. When an agent invokes a tool gated by always asked, the session initiates a four-step programmatic handshake. Step 1. The server emits a tool use event describing the intent, like removing a file. Step 2. The session idles with requires action, providing event IDs. Step 3. Your client application intercepts the payload for a live inspection of the actual command string. This live check is more expressive than a static rule, deciding on the concrete request. Step 4. Confirming the call sends a confirmation event back, resolving the block so the session resumes. Because this handshake is a strict requirement, there are two primary failure modes to avoid. The first is a partial answer. If the server lists 3 blocking calls and you only resolve 2 of them, the session will wait forever on the third, appearing to hang. The second is an unanswered gate. If you set a tool to always ask, but your code doesn't handle the requires action event, the agent will hit a permanent stall the first time it tries to use that tool. If you choose to gate a tool, you must be prepared to resolve the confirmation flow perfectly every time. Let's return to the agent attempting to overwrite the production ledger. If you issue a bare, unexplained rejection, the agent simply stops and has to guess why it was blocked. The deny message field solves this. Instead of just no, provide feedback. That writes to the production ledger, use staging instead. This message fades back into the agent's context. The agent adapts, generating a new tool called targeting the safe staging environment. This turns the permission system into a steering wheel. You aren't just blocking dangerous actions, you are providing the guidance the agent needs to complete the task safely. By combining these two simple policies with live inspection and contextual feedback, you can give an agent the full power of the shell while maintaining practical, predictable control over every action it takes.